Sponsored by Panasonic. Smart factory solutions for any mix, any volume. Introducing the new NPM W2S, the ideal placement solution for manufacturers who value reduced setup and changeover time over volume.
Okay, welcome to the KIC booth here at IPC APEX. I'm joined by Chris Nash from Indium and MB Allen because between them they are running a clinic for those of you that are having issues with voiding. Voiding's been around the industry now for quite a while, and it's one of the big issues. What is your clinic? What is the approach of your clinic to the voiding problem? Let's start.
So the clinic's really all about collaboration within the industry, and KIC and Indium have been partners on a lot of things throughout the years, and we want to bring our expertise to the industry as a partnership. So that the voiding has really been a problem that's been plaguing the industry, whether it's thermal reliability or mechanical reliability. So it's all about reliability in that terms. So trying to help our customers, especially mutual customers, figure out how to reduce voiding is extremely important. We can do that with a number of different ways, whether it be process, material, or some other techniques as well.
Okay. Well, we know that the technique, obviously, that Indium came out with was a low voiding flux material that helped reduce the voids. You're taking an approach from the profiling side, so tell me a little bit about how you come into this.
So obviously their materials have been very, very successful with reducing voiding. There are some customers that also have certain specifications that they have to use an existing material and cannot change to a lower voiding material, and one of the solutions for that is to address the profile itself. But as well as with a low voiding material, there may be a specific profile that will help to reduce the voids. So there are various ways that you can do that. In some cases we may suggest, or you may suggest, that you eliminate the soak, and you may do a ramp to peak, or you may have slightly higher peak. Of course, that incurs some problems as well if you have some sensitive components. What our solution would be, then you can still do that and set a different process window around the sensitive component. So our software is extremely flexible to help optimize within the specific requirements of both the materials and the components, and try to get that lower voiding
Recipe.
Exactly.
Trying to get the right recipe, because you've got obviously the materials knowledge and how that behaves, and together you come up with the best option. And the idea behind this, I understand it, is that you're trying to come up with solutions for customers that are relatively cost effective and quick to do.
Absolutely, absolutely. Yes, I mean, there are, as Chris mentioned, there are other solutions that could be quite costly, and also that will take some time for qualification or to make certain changes. But these materials, along with a solder recipe, are almost instantaneous changes. So a customer has that problem today, they don't have the luxury of waiting to figure out how to resolve that problem and get the product back to the customer. So
Chris, does this depend on the percentage voiding number that the customer is trying to achieve as to whether this will work, or whether he has to also add a mechanical agent?
Sure, I think some of the specs that we've seen, and they're all really customer-driven specs, because there isn't a standard out there for bottom termination component voiding. BGA voiding is another scenario. However, you really don't have a lot of people complaining about BGA type voiding or CSP voiding these days. We've kind of reduced that with materials throughout the years. So the percentages that we're seeing are replicating or mimicking the BGA type voiding, less than 25%, as the IPC states. Some companies are pushing even further, especially in the automotive realm, where they want 10 to 15% voiding, 5% voiding in some cases, and we have seen some specifications, very, very difficult specifications to meet, with 2.5% or less voiding.
In automotive?
In automotive,
wow.
Yes. So I think a lot of these are arbitrary numbers that they're pulling out of thin air, but it is what it is. You know, they want a certain level of voiding no matter what, and they'll do anything it takes to get to that point.
Right.
So you know, we've studied it a lot over the years. There's a lot of variables that go into it. This board, you know, with this metal component or this metallization on the board, even some of the board thicknesses will create an issue where the profiling will come into effect. So there are a lot of variables to consider here with voiding, thousands probably. We've done Ishikawa diagrams where we've listed out the causes and effects of voiding, especially bottom termination component voiding. And you know, there's just so many variables that go into effect here that it's hard to pinpoint, you know, it's the paste or it's the profile or it's the board metallization or it's the stencil design or stencil thickness, so on and so forth. So getting down to those challenging percentages is quite difficult in some cases, but there are certain techniques that can be employed to reduce voiding even further. And obviously the goal is 0%, right? But that's going to be extremely difficult. It's all about reducing voiding to a level where your reliability is not compromised.
Exactly. So let's talk about the clinic itself here. Are you expecting customers to come in with...
Starting to come in early this morning and saying, what time is it, what time will it be? So we're actually in the middle of that time frame right now, but they're welcome to come at any time.
So are you expecting them to bring in some samples, or you have samples here, or how are you approaching?
We have samples of voiding, you mean? Yes. Samples of voids? No, I don't believe so. I think the whole point is for them to ask questions. You know, here's my process, here's my problem. Can you help me with some solutions? Obviously, if it's a material-based solution, as soon as this is over, they can certainly get to the Indium booth and get some samples. We have some here as well. We've worked together in developing some profiles as well that will address it, so we can show them within the KIC software on how to resolve that. So I think you made a really good point about BGAs earlier on in the conversation, and then now where there's so many different areas. BGA voiding was such an issue with the transition to lead-free, and it's been somewhat tackled. And I think that, again, Chris mentioned, yes, there are solutions, but you also have the components themselves. You know, that's another area that has to be evaluated to see if the component itself was part of the problem. Right. So there are so many things, and I think customers don't always... Exactly.
Even moisture in the components will cause voiding, or contamination on the surface finish of the component could be an effect of voiding.
Right. So I'm guessing you two do this collaboration for your joint customers at home anyway.
We do. If I don't think there's a page that you can't find on the web that doesn't have an article that Indium has done on voiding. It's just phenomenal work and so helpful to people. The thing is to bring the answer to an individual. That's what our goal is here today, because I'm in my office, they're at their facility, they're having a problem, they want to know an answer right away. So this gives them an opportunity of meeting, you know, people in two companies that have worked with other customers that have the problems, and then to bring their own problems here and offer a solution for them.
Great idea. Okay, so there you go. So that's what's happening here at the KIC and Indium clinic. Thank you for joining us today.